Hi, I'm Jaden, and in this video I'm going to talk about vectors. Here's an overview of the video. We'll cover drawing, addition, and multiplication of vectors. A vector has a magnitude and a direction. The tail of the vector is the starting point, which is A, and the head of the vector is the final point, which is B. A vector is written as the letters of its head and tail with an arrow above it. We can picture 2D vectors on a Cartesian plane. To determine the coordinates of a vector, which is vector A in a plane, the first step is to translate the vector so that its tail is at the origin of the coordinate system. Then the head of the vector will be at some point of A1, A2 in the plane. To find the components of vector A is simply just subtract the respective components. A1 minus 0, A2 minus 0, and the final product is A1, A2. The magnitude of a vector is the length of the vector. Using the same set of vectors, we can find the magnitude by using the formula of square root of a1 squared plus a2 squared, which is deduced from the Pythagorean theorem. The direction of the vector is the slope of the segment from its tail to its head. Using the same vector, the slope is a2 over a1, which is the change in y over the change in x. Now, we'll talk about the addition of vector. Vector A is a1, a2. Vector B is b1, b2. What would it be if we add them together? Graphically, we translate the vector B until its tail touches with the head of A. We just have to add the components together, so the sum will be a1 plus b1, a2 plus b2. Addition is similar to subtraction. Using the same set of vectors, what happens if vector A minus vector B? In subtraction, we have to reverse the direction of the vector we want to subtract, as shown in this diagram. The answer will be the subtraction of the components, which means a1 minus b1, a2 minus b2. In multiplication, there are two types, the multiplication of a vector by a scalar and the multiplication of a vector by another vector, which is the dot product. First, the multiplication of a vector by a scalar. A vector has a magnitude and direction, while a scalar has only a magnitude. When we scale a vector, we change how big or small the vector is. Vector AB is 3, 4. We multiply it by a scalar of 3. First, we have to multiply each component by 3. 3 times 3, 4 times 3. And the final product is 9, 12. The vector has the same direction as the initial one, but 3 times longer. To flip the direction of a vector, we simply multiply the vector by a scalar of -1. We multiply the vector 3, 4 by a scale of -1, so the result will be -3, -4. It has the opposite direction from the initial one, but has the same length. The addition of 3D vectors is the same concept of 2D vectors, in which we add the respective components together. Using the above sets of vectors, the sum will be a1 plus b1, a2 plus b2, a3 plus b3. The subtraction of 3D vectors is the same concept with 2D vectors, in which we subtract the corresponding component. Using the same set of vectors, the answer will be a1 minus b1, a2 minus b2, a3 minus b3. The multiplication of a vector by a scalar in 3D is the same concept as 2D. If we multiply vector A by the scalar of k, we still multiply each component by k, and the result will be a1k, a2k, a3k. The multiplication of a vector by another vector, which is commonly known as dot product, is used to find if the two vectors are perpendicular to each other. We can perform that by multiplying the corresponding elements of both vectors and add the products up. Using the same set of vectors, we can see the dot product of vector A and vector B is simply multiplying the corresponding components together and adding them up, resulting in a1b1 plus a2b2 plus a3b3. If the final product is 0, the two vectors are perpendicular. Here's an example. Vector A is 1, 0, -2. Vector B is 2, 1, 1. As shown, the dot product of vector A and vector B equals to 0. Since the dot product is 0, the two vectors are perpendicular to each other. So here's the practice problem. We have to find the coordinates of John and its distance from our origin. The first step is to find the vector of the origin to the final point. So the origin is 0, 0, and the final point is 12, 15. To find the components, we have to subtract the components. 12 minus 0, 15 minus 0, and the answer is 12, 15. Then, we have to scale the vector by 1/3, since John only walked 1/3 times distance. So 12, 15 times 1/3, 12 times 1/3, 15 times 1/3, and the vector is 4, 5. We apply the vector to the starting point to find John's coordinates. So 0, 0 plus the vector 4, 5, and the coordinates are 4, 5. And the coordinates of John is 4, 5. We find the magnitude of a vector to find John's distance from the origin. So the square root of 4 squared plus 5 squared equals square root of 16 plus 25 equals the square root of 41. So the distance between John's position and the origin is the square root of 41. Thank you for watching.